Today in class we talked about literal equations. As it says up there, a literal equation is an equation where variables represent known values. What that means is it's an equation where, like, for example, if I look at this formula, A equals 1/2 BH, which is the formula for the area of a triangle, I know that A represents area, B represents the base, H represents the height. I know what these values are. I may not know their exact number right now, but these are values that I'm aware of in the real world. Okay, same like this. I have pi, which is a constant. R is radius, H is height, V is volume. So these have known values. Now, in the past, you've used these formulas. You've substituted in like base and height, solved, and figured out what A was, and you got a single number answer. Or you substituted in R and H, and you got the answer for volume. In the past, you've also been told the volume is something, the radius is this, how tall is the cylinder, and you had to work backwards. What we're going to do is we're going to transform these equations, but we're not going to end up getting a number. We're going to take them and make them look like something else. So when I think of transformations, I literally think of the transformers. Okay, so here's Optimus Prime, right? Optimus Prime he's just sitting there, and he's a transformer. Okay, he's sitting there, and when he does his thing, he transforms into a truck, right? He's still the same Optimus Prime. He's still got all the same innards and all the same guts. They just rearranged so that he could look like a truck instead of looking like a robot, okay? And that's what we're going to do here. We're going to take these equations, we're going to take these values, we're going to rearrange them so that instead of being A equals, we're going to have B equals. So that's all we're doing is we're rearranging and we're transforming from one form of this equation into another. So we're going to do a few examples. The first example we're going to do is that one we were just talking about. We're going to do A equals 1/2 BH. Okay, and it says for B. When you see for B or in terms of B, what is going on here? Okay, when we see for B or in terms of B, that means instead of being A equals, I want it to be B equals. So I want the B isolated. So I'm going to do whatever I have to, add, subtract, multiply, or divide, to get this B by itself. In order for me to figure out what I'm going to do, I got to figure out what's happening right now. Right now I have 1/2 times B times H. I don't like this fraction, so the first thing I'm going to do is I'm going to scale my entire equation up by 2. So I'm going to double everything, and that's going to get this fraction out of the way. Now remember, if I don't double everything, just like with a proportion, if I don't use my scale factor on every single piece of the equation, then I'm not going to be able to solve this problem. It's not going to work. It's not going to be an equivalent expression, and that's what I'm looking for. So 2 times A is 2A. 2 times 1/2 is 1. I don't even need to write that, and leaves behind only BH. Okay, so I'm getting closer. Now all that's with the B is H. This is B times H. If I want to undo B times H, I divide by H. Okay, so I have 2A over H equals B. It's in terms of B now. I've solved for B. So even though it's not a number, this is my answer. I'm not trying to find a single letter. I'm trying to transform this so that instead of looking like a robot, it looks like a truck. In this case, I don't want it to look like an A. I want it to look like a B. And I've made that transformation successfully. Let's try another one. Okay, the second example I'm going to do. V equals pi r squared h. And it says for h. So since we're solving for h, I'm going to circle the H. I circle it because I'm trying to draw my attention to it. I'm telling my brain it's important. Pay attention to this. So I'm going to circle it. All right. Now, if I look, what's happening is I have pi times r squared times h. Well, to undo multiplication, I divide. Now, I could do this one step at a time, and that's not a problem, but I can also knock both of those steps out at once because I'm lazy and I don't like to do extra work. If I divide one side by pi r squared, I got to divide the other side by pi r squared. Again, it's just like when I scaled here. If I multiply this side by 2, I got to multiply that side by 2 also. I got to keep my equation balanced. If I don't scale everything equally, then I'm not going to have an equivalent equation, equivalent term, it's not going to work. It's going to be wrong. Okay, let's leave it at that. My pi's cancel out, my r squares cancel out, and all that's left over there is h. So I have v over pi r squared equals h. I wanted it in terms of h. It's in terms of h, so I'm done. Let's try another one. We have ax plus, that's an x, plus by equals c. And it says for y. Okay, so that means y is what I'm going to try and isolate. Now, in class today, we had a lot of people could not figure out, am I going to divide by b first, or am I going to multiply, or am I going to subtract ax first? If we look at a problem like this, 7 minus 5x equals, I don't know, 13. I'm just making up numbers here, okay? What do I have to do first here? Well, I have to get rid of this 7 because I can't divide by negative 5 until I subtract this 7. It's the same thing here. I can't divide until all I have on this side of the equal sign is my y term, which includes the b at this time. So I'm going to subtract ax from both sides. That zeroes out. So I have by equals c minus ax. I can't combine these two things because those are chickens and those are mangoes. I can't put them together. I can't combine a dancing bear and a screwdriver. They're not the same kind of thing. I can't combine them together. All right, now, what I have here is b times y. So to get the y by itself, I'm going to divide both sides by b. So I have y equals c minus ax over b. That's one way you might see it. You might also see it like this. C over b minus ax over b. These are both correct expressions, correct equations. You might see it either of these ways. Later on, we're going to do a problem where you kind of have to write it this way. Okay, let's look at a different problem. This one it's a little crazy looking, but, you know, it'll be all right. F over g equals h over j, and they want me to solve for j. Okay, so j is what I'm getting isolated. Earlier today in my first classes when I taught it, I talked about multiplying both sides by j and then multiplying both sides by g and then isolating the j. Later in the day, a student asked me about a property of proportions that we can use to solve this. So I'm going to show y'all how to do it this way just in case you want to see it. Proportions. One of the properties of proportions, and this is a proportion because I have ratio equals ratio. This is a proportion. One of the properties of proportions is that proportions, the cross products are equal. So that means if cross means across from each other, products means multiply. So if I multiply these together and I multiply these together, they're equal. That's a property of that's a property of proportions. So I can skip about 3 steps of showing my 3 rows of showing my steps just by using this property of proportions. I can multiply this and multiply this and set them equal. Okay? Now, again, I'm trying to get j by itself. Well, right now, I'm taking j and multiplying it by f. Well, let's divide by f to get that f away from my j. Well, now I've got j equals gh over f. I wanted it for j. I've got it for j. I'm good to go. All right. This next one is actually one of the ways that we most typically in algebra, one of the things that we most typically do, although this isn't really in standard form. Although it really isn't officially in standard form because we're not allowed to have fraction coefficients, it's closer. So again, the first thing I'm going to do with this one, I don't like the 3. I don't like denominators. So I'm going to scale my entire equation up by 3. Okay? So 3 times 6x is 18x. 3 times 2 is 6. 6 divided by 3 is positive 2y. 3 times 10 is 30. Now again, I want y to be isolated. I have this whole other term. Remember, I can't divide by 2 until all that's on this side of the equal sign is 2y. So I got to get rid of this 18x. I'm going to subtract 18x. Okay, that zeroes out. I have 2y equals, it doesn't matter whether you say 30 minus 18x or negative 18x plus 30. Let's do 30 minus 18x because I don't like having a negative in the front, okay? Now I can divide by 2. Now, some of you are going to want to leave it like this, but you can't because this is not simplified. If I separated this out and put 30 over 2 minus 18x over 2, I can simplify both of those fractions. So in this case, I have to separate them out because I have to simplify them. So 30 over 2, whoopsie, 30 over 2 is 15. 18 over 2 is negative 9x. And this is my final answer. Of course, if you have that, also the same thing. Also a perfectly fine answer. Okay? The last one I'm going to do with you is actually one of the ones that was on your homework. It's the area of a trapezoid. So it's h times b1 plus b2 over 2. This is straight up crazy looking, but it's really not that bad. Okay? Again, y'all know I don't like the denominator, so I'm going to multiply, scale everything up by 2. 2 times a is 2a. 2 times all that stuff over 2 makes the 2's go away, and I have h times b1 plus b2. Now, a lot of people today have said, why don't we just distribute that? Well, because if we distribute it, if we multiply it, we're then just going to have to divide it later. But what I see is that I have h times all this stuff. And again, I'm sorry, this was for b2, by the way. Okay, I want b2 by itself. So if I divide everything by h, that's gone, and I'm much closer, and I don't have to do any extra steps. Okay, now I want b2 by itself, so I'm going to subtract b1 from both sides, and I get 2a over h, minus b1 equals b2. I've seen a lot of people today trying to write it like this. This is wrong because you can't do that. Just like over here, we could kind of almost like distribute this 2 denominator. We can't do that. This b1 doesn't have an h in its denominator, so they don't have a common denominator. We can't do that. We have to write it like this. This is wrong. Boo. Okay? So these are the examples I've got for you for literal equations. Hopefully this will help you out when you try to solve them. And have a good day.